All right, let's get started. Welcome to our webinar for today. My name is Justin D'Souza. I'm a quantitative specialist at Statistics Solutions. During today's webinar, we will be discussing how to select statistical analyses for your research. I have a colleague, Melissa, who will be assisting me with questions today. So if you have any questions during the webinar, please type them into the question and answer box or the chat box, and Melissa will answer those questions. And at the end of the webinar, I will address any questions pertaining to the topic today. All right, let's go ahead and dive into today's topic. We will start out by giving an overview of the services that Statistics Solutions provides. Then we will discuss how to select an appropriate statistical analysis. I will provide a brief demo in Intellectus Statistics for how you can select your analyses, and we will conclude with a summary. We have a couple links here in the webinar, and we're going to send everyone a copy of the PowerPoint. So these two links provide they're links to the past webinars we've done and future webinars that we are going to be conducting in the future. So when you come to these two links, you'll see a list of the webinar archive, which has topics we've discussed in the past. And you can see and register for upcoming webinars that we will be conducting. We discuss a variety of topics ranging from the introduction, literature review, and methodology, all the way up to the results chapter, specific topics about statistical analyses and the discussion piece. All right, so the topic today is about selecting your statistical analyses, and the choice of what statistical analysis you're going to use is highly dependent on the level of measurement for the variables you're examining. So you can have continuous variables, you can have nominal variables, or ordinal variables. Most variables fall into one of these three categories. So a continuous variable is a variable that falls on a continuum, such as test scores, temperature measured in Fahrenheit or Celsius, weight measured in pounds, composite scores from a previously validated instrument. So if you're following scoring instructions from a previously validated tool, typically if you're using Likert scale data, you'll take an average or a sum of several items to generate a composite score. That composite score is a continuous variable. We have nominal variables, which are comprised of categories. So there's no intrinsic order to these. They're not strictly numbers. They're things like gender, ethnicity, or passing and failing of an exam. So variables that can be assigned into categories. We have ordinal variables, which is a subset of nominal variables, but it's more specific. It's a variable that can be ordered or ranked. Some examples of this include education, maybe income, if you're in the income bracket. If you give a question on a multiple choice and you ask someone to select what income bracket they are, or individual ordinal items on a survey. So a Likert scale, if you're just examining one item on a Likert scale, and it falls maybe from strongly agree to strongly disagree, that would be an example of an ordinal variable. So the first type of test, or first test family, I should say, are correlation tests. And generally, the research question for this is testing whether you have a significant relationship between variable 1 and variable 2. Now, with correlations, you don't necessarily need to have an independent and dependent variable. You just have two variables of interest. And depending on the combination of variables you are examining and the level of measurement of those variables, you will most likely need to use a specific analysis to address that question. For example, if you have two continuous variables, you would use what's called a Pearson correlation. This is considered a parametric analysis. So a sample research question for this would be, what is the relationship between self-esteem and self-efficacy? There are many tools and instruments that can be used to measure self-esteem and self-efficacy. And most of those are composite scores. So you're taking an average of Likert scale data. So this would be a good example of using a Pearson correlation. If you have an ordinal variable and a continuous variable, the correct approach is to use a Spearman correlation. So an example of this would be, what is the relationship between education and self-esteem? So education is typically considered an ordinal variable because there is a natural ranking to the variable, maybe less than high school, bachelor's, master's, PhD. It goes up a natural progression. That would be considered an ordinal, and continuous would be self-esteem, just like it was in the previous example. So when you have an ordinal and continuous variable, typically you want to use a Spearman correlation. The same idea applies when you have two ordinal variables. So ordinal for your first and ordinal for your second variable. You want to use a Spearman correlation again. So the prerequisite to running a Spearman correlation is that you have at least one ordinal variable. An example of this would be, what is the relationship between education level and income bracket? Like I said in the previous slide, income bracket, also like education, has a natural progression in the ranking. That would be considered ordinal. If you have a dichotomous variable and a continuous variable, you need to run a subset of a Pearson correlation, which is called a point biserial correlation. I say a subset because the math that is used to calculate a point biserial correlation is very similar to a Pearson correlation. So it is considered a parametric analysis. And I should have mentioned that a Spearman correlation is considered a non-parametric analysis. So an example of this, what's a dichotomous variable? A dichotomous variable is anything that can be branched into two possibilities. Gender, if it's male and female, passing and failing of an exam. Those are considered dichotomous. So if you have a dichotomous and continuous variable, this is a good chance to use a point biserial correlation. And then we have the comparison between two nominal variables. So a variable like gender and a variable like ethnicity. If you're looking at the association between two categorical constructs, you want to use a chi-square test. Okay, so correlations are generally the more straightforward of the analyses. Like I said, you don't need an independent and dependent variable. When you go to the next test family, regressions, you need to identify a predictor, which is considered your independent variable, and you need a criterion variable, considered a dependent variable. So all of these are going to be regressions on this slide, and the choice of which regression to use is 100% dependent on what your criterion variable is. So how is your dependent variable being measured? As you can see, it doesn't matter what your predictor variable, what type of measurement your predictor variable is using. You can have continuous, ordinal, or nominal variables, and you can have multiple predictors as well. But you need to have one variable for your criterion variable. And if you have a continuous outcome, you use what's called a linear regression. So as we discussed, self-esteem is a continuous variable because it's being developed by a composite score. If you have a dichotomous outcome, such as passing and failing of an exam, then you want to use a binary logistic regression, binary meaning two outcomes. If you have more than two outcomes, such as ethnicity, so you had several choices for ethnicity, white, black, Asian, and Hispanic, you would need to use a multinomial logistic regression to predict ethnicity. And if you have an ordinal outcome variable or dependent variable, which is income bracket, then you need to use an ordinal logistic regression. So we've covered correlations and we've covered prediction. So whenever you see the word prediction, I'm going back to the previous slide, predictive is the key word here. Whenever you see predict, you can assume that regression is going to be utilized. Now, the next key word would be differences. How do you test for differences between groups? So there are many analyses to run for this, and we have both parametric and non-parametric options. So if you have a dichotomous independent variable, such as gender, and you have a continuous dependent variable, such as self-esteem, you can run what's called an independent sample t-test. For instance, are there significant differences in self-esteem between males and females? So this independent sample t-test is going to tell you specifically what are the mean scores for self-esteem among males and what are the mean scores for females. And the test will tell you if there's a significant change between males and females. If you have a nominal variable, so 3 or more groups, taking the idea of a t-test, but expanding it further. So not just 2 groups, we can have 3 or more. In this example, you want to use what's called an Anova. It's an analysis of variance. So this is testing for differences in a grouping variable or an independent variable with 3 or more groups. But you also need a continuous dependent variable like self-esteem or weight or height or GPA. Taking the idea of an ANOVA, we can also add multiple continuous variables at once and still look for differences by a nominal variable with 3 or more groups. For instance, are there differences in self-esteem and self-efficacy between ethnicities? So in this example, we have 2 dependent variables of self-esteem and self-efficacy, and we want to simultaneously assess for differences by ethnicity. In this example, you would want to use a MANOVA. So these first 3 examples we discussed are the parametric options, t-tests, ANOVA, and MANOVA. Now we're going to get into non-parametric options. So a non-parametric test is pretty much used when you have an ordinal variable instead of a continuous variable. So if your dependent is ordinal, such as education, and you're looking for differences in a dichotomous variable, 2 groups, then you would use what's called a Mann-Whitney U-test. So a Mann-Whitney U-test is very similar to an independent sample t-test, as you can see up here. We're looking for differences in a variable between 2 groups. However, our dependent variable has a alternative level of measurement. We have a continuous variable for a t-test, and we have an ordinal variable or a Mann-Whitney U. In a similar way, a Kruskal-Wallis test is the non-parametric alternative to an ANOVA. When you have an ordinal dependent variable instead of a continuous dependent variable, and you are looking for differences in the groups, then you run a Kruskal-Wallis test. For instance, are there differences in education level? That's an ordinal variable between ethnicities. So here we can still look at tests of differences, but now we can add a factor of time. So this is typically done with interventions or experimental studies. You're looking for a change before and after an intervention has been applied. So if you have one measure, say you're measuring job satisfaction among employees, you administer the survey, then you apply an intervention in the middle with hopes of improving job satisfaction. and then you give a post-test to measure their job satisfaction level. This would be an example of a dependent sample t-test. A dependent sample t-test is used when you only have 2 points of time in comparison. So we only have a pre-test and a post-test, and we have a continuous dependent variable. So I'm assuming here job satisfaction, there are several surveys to measure job satisfaction that use a Likert scale, and you can develop a composite score to measure this variable. Expanding the idea further beyond just pre and post, what if you want to look at differences in 3 points in time, pre, post, and maybe a follow-up? Here, you need to use a repeated measures ANOVA. This would be a sample research question. Do we have differences in job satisfaction between pre-test, post-test, and follow-up? Okay, so we still have job satisfaction. And I should have mentioned an important component of doing differences over time is that you match participants. So the same participants who are taking the pre-test also need to be taking the post-test. You need to assign an ID number, or you need to be able to match the people so you can match their scores between pre and post. So the dependent sample t-test and the repeated measures ANOVA are parametric analyses. Now, remember when we use ordinal variables, that's when it typically becomes non-parametric. So the non-parametric alternative to a dependent sample t-test, this is also called a paired sample t-test. It means the same thing. The non-parametric alternative to that is a Wilcoxon signed rank test. So that's used when you have 2 ordinal variables, or really 1 ordinal variable that's measured twice. So like income bracket, if you measure income bracket at pre-test, you administer an intervention, and maybe years in the future, you see what income bracket the participants are in. That would be a time to use a Wilcoxon signed rank test. Expanding that idea further, we can introduce 3 or more time points, so pre, post, and follow-up potentially. So the same ordinal variable applies here. This is a non-parametric analysis as well. We would use what's called a Friedman ANOVA. So a Friedman ANOVA is the non-parametric alternative to a repeated measures ANOVA. Repeated measures ANOVA needs a continuous variable, and a Friedman ANOVA typically needs an ordinal variable. Now, a way to combine the ideas of the previous slide, how do we look for differences between groups and over time simultaneously? That's when you run something called a mixed model ANOVA. This is done mainly in experimental studies. Through experimental studies, you assign participants randomly to a treatment and control group at the beginning. You administer a pre-test, you apply an intervention, and then you record your measurement again following the intervention. That is when you would use a mixed model ANOVA, and you need a continuous variable, a continuous dependent variable to run that. So there are 3 effects you need to look for in a mixed model ANOVA. You need to look for what's called the within effect. That's assessing if you have differences over time. You need to assess the between group effect. That's telling you, do you have differences between your groups, meaning treatment and control? And then you need to assess the interaction effect. So that's putting time and group together. So are there differences between pre and post and treatment and control simultaneously? So imagine that you have a grid and you have 4 possibilities. You have pre-test treatment, pre-test control, and then post-test treatment, post-test control. Mixed model ANOVA is testing for differences among all 4 of those possibilities. Okay, so that covers our topic for today. So you have to first determine what level of measurement for the variables you're using. You want to identify if you're looking for a 2-way relationship, in which case you use correlations. you want to identify if there's a predictive relationship. So you have an independent variable and a dependent variable, or they're called predictor and criterion as well. That's when you want to use regressions. If you're looking for differences between groups, that's when you're typically going to independent sample t-tests or ANOVAs, tests of differences over time. You have paired sample t-tests or dependent sample t-tests, and tests like a repeated measures ANOVA or a mixed model ANOVA if you're looking for differences over time and between groups. So I can show you a demo of our company's software. This is Intellective Statistics, and Intellective Statistics is mainly used for analyzing data and presenting an APA write-up. So just to show you an example here, I've uploaded a spreadsheet and I've already run some analyses here. So we have a group of options that you can conduct, and you can even edit your data here. So we have several data management functions, but this is way better than SPSS or SAS because you can analyze your data and it provides an APA write-up automatically, and it puts the tables in APA format, and it tests for assumptions. We have a series of tests that you can conduct, descriptives, correlations. We touched on many of these today. Z-tests, proportion tests, t-tests, ANOVAs, MANOVAs, several regression models, non-parametrics. We even have path modeling analyses like SEM, CFA, and PLS. And we have advanced analyses like mediation, moderation, time series. But the useful for today's topic, the useful tool in here would be a decision tree. So if you're at the methodology phase and you don't know what analysis you need to run, you can use our decision tree to help guide your correct selection of what analysis to use. So you can see we have a series of questions at the top. So say I want to predict an outcome. It's going to start the decision tree. What is the level of measurement of the variable you want to predict? Say it is scale. It's a continuous variable. It's going to go down the decision tree and suggest the best statistical option for you to address your research question. And likewise, we can also test for differences. I want to explore for differences between groups. Do you have more than one dependent variable? Say, no, I just have one dependent variable. Do you have covariates? No covariates. You have more than one independent variable? No, it's just one independent variable and only two levels. You'll see it's going to go all the way down the decision tree and say you should probably use a t-test or a Mann-Whitney U-test. So almost every analysis we touched on today is discussed here. Okay, so that covers our topic for today. Just to reiterate, Statistics Solutions provides assistance with every portion of the dissertation. So starting with topic development, constructing your research questions, developing a prospectus. We help with all those portions and go all the way through the proposal, introduction, literature review, and methodology. And we assist with the results chapter. So we can help you crunch your numbers if you have data. And then we can help you interpret those findings and put it into an APA compliant document. And we assist with the discussion chapter, which is usually the final chapter of a dissertation. And we can assist with preparation for the defense. So our company, what we'll do is we'll assign a methodologist to you. So if you're doing a quantitative study, we can assign a quantitative methodologist. If you're doing a qualitative study, we have qualitative specialists as well. And we have a literature review specialist. Depending on where you need help, you may receive 2 specialists or 1 specialist, and they will help guide you through the dissertation edits and any feedback you may receive from your committee. If you have any questions about the services we provide, you can contact us at info@statisticsolutions.com, or you can give us a phone call at 727-442-4290. So that concludes the presentation for today. I will now go through questions, if we have any, regarding today's topic. All right, looks like we have a question from Charles. He asked, what analysis do I use for nominal and continuous variables in an associative relationship question? Unfortunately, there aren't many options for that. If your nominal variable is dichotomous in that it has two possibilities, yes and no, you can use a point biserial correlation. You could also use a linear regression, potentially. It gets a little more complicated because you have to do what's called dummy coding. So you have to dummy code your nominal variable if it has multiple possibilities. So that's a pretty in-depth topic. If you're not familiar with dummy coding, I would recommend checking it out on YouTube or just Google what is dummy coding, and they will explain it. An alternative could even be to run an Anova. So that's changing you asked how to do an associative relationship question. This would be more for differences, but if you swap your continuous variable as your dependent variable, are there differences in your continuous variable between your nominal groups? That would be an Anova. So you have many possibilities. If you want to keep it as a relationship question, I would say probably a linear regression is the best option, but you have to dummy code your nominal variable. Okay, yes, we will be sending a recording of the slides to everybody. Okay, do we have any additional questions? Are there any resources you would recommend for mixed methods research? It's a good question. I don't have many for qualitative. I'm not a qualitative specialist, but for quantitative, it depends what you're looking for. I would say a very general reference is Creswell. Creswell is used many times, and they release a book every couple years, I want to say. So Creswell talks about both quantitative and qualitative methodologies. I would also take a look at Howell. Howell, it more discusses analysis, as does Tabachnik and Friedel. So I'll type those in the chat box, okay? And you can take a look at those. So Tabachnik, Friedel, 2013, I think is the most recent one. And Howell, 2013. Those are good ones. They're more statistics related, maybe not general methods as you're looking for. If you're looking for general methods, I think Howell does touch on that, but Creswell is probably your best bet. Okay, we have a question from Nilly. When would we use a time series? So a time series would be used when you have repeat measurements over time. So you have, this is talking about measurements that are taken consistently over years typically. So maybe 4 to 5 measurements used per year, and then it's extrapolated over many years. That's typically when you use a time series, and there's usually an effect in the middle. So something has changed where you want to evaluate if that impacted the model or not. So usually it's an extrapolation of data over many years, and typically there's something that has caused the data to change in the middle, and that is your hypothesis. Okay, I did type it in the chat box. Maybe I didn't send it to everybody. Melissa just sent it to everybody. I think I sent it to the panelists by mistake. So Melissa just added those citations. If you just give me a moment, I can actually give you the references as well. Howell 2013 might not be enough to find it. Okay, I did it correctly this time. That's going to everybody, to Bachnick and Fidel, and let's find the Howell one. This is for Howell. Let me see if I have anything else. This is the Creswell reference. Here's another one. This is more quantitative citation, Bordens and Abbott. Okay, so let's see, we have a question. Which tests should I use to test the effects of an intervention program in a third language on second and first languages? I think I'll need to know more information to assess that. So if you can identify for me, what is your independent variable? What is your dependent variable? How many points in time? So what is the effects of an intervention program in a third language on second and first languages? Yeah, I can't fully answer that question because I don't really see anything that is numeric in that research question. Okay, so let me take a look and see if you had any other questions. All right, do we have any additional questions? Hi, Yaleen. I see you raised your hand. If you can type your question into the chat box. Glad to hear it was helpful. Thanks for joining. Thanks for joining. Yes, and we're going to send a copy of the PowerPoint and a recording to everyone. And please join us for our next webinars as well. We'll be doing 4, I believe it'll be up to 8 of these a month. So we have 4 specialists who do them, and they do 2 a month. So altogether, there'll be 4 topics. Come join us again. Okay, so the independent variable is a 4-month intervention program focusing on meta-linguistic skills in English, and the dependent variables are the same skills in French and Arabic. So is meta-linguistic skills a numerically measurable variable? So is it continuous? suppose I don't fully understand. So metalinguistic skills in English is not a dependent variable, but it is in French and Arabic. That doesn't fully make sense to me. If everybody has a metalinguistic skills variable at pre-test and they do it post-test, yeah, I suppose I'm just not familiar with this type of design specifically. Reverse transfer of skills. Yeah, sorry, I'm not really familiar with this specific approach, but it sounds like it would be, you could just use, there's only 2 points in time and you have metalinguistic skills being measured in French and Arabic, then you could use a repeated measures Anova. I want to say is your best bet. Okay, we have a question. Are chi-square tests valid for determining differences in groups when both variables, the grouping variable and the other variable, are dichotomous? That is correct. Yep, you want to use a chi-square test. Yep. Thanks for joining, Hassan. Sorry if I couldn't answer your question fully. I think I would need to see specifically how the data is set up. But it sounds like a repeated measures Anova to me. All right, do we have any additional questions? Thanks for joining, everyone. Remember, you can email us at info@statisticsolutions.com, or you can give us a call at 727-442-4290. Okay, I'll stay on for a few more minutes if we have any last questions. I think we answered all the Q&A questions. If you did ask a question in the Q&A, could you please type it again? Okay, yeah. Can you show the slide for the differences between groups? Sure thing. Let me find that one. Okay. When the dependent variable is dichotomous. That's a very specific example. It's actually not on the slide. So you'll use what's called a, most likely a chi-square test. But if it's differences over time for the same group and your dependent variable is dichotomous, you want to run a Macnamar's test. Well, let me open Intellectus and we actually discuss that here. So under non-parametrics, so as I hover over this, you can see a Macnamar's test. That's the relationship between two dichotomous variables that can be matched together. So you need to have a pre and post to run this. If you don't have a pre and post, then you're most likely going to use a chi-square test of independence. because you have two nominal variables. Yep, you're welcome. All right, any final questions? Here you can see the future webinars we'll be conducting. So it looks like tomorrow, my colleague David will be doing a webinar between 2 and 3 p.m. Eastern, and we'll be discussing how to present quantitative results. And this Friday, we'll be discussing how to present qualitative results. All right, everyone, thank you for joining. Let us know if you have any questions. Contact us if you've hit a roadblock in your dissertation, and we can certainly help you get through that roadblock. Let us know how we can assist. Come join us again for our future webinars. Have a great evening.